So you learned in 8.1 about this sequence, a geometric sequence and an arithmetic sequence, and today you are going to listen and learn about arithmetic series and geometric series. We have two different types of series. They are either an infinite series, a series that goes on forever and ever, or a finite series which has a certain amount of terms. In a series, what is the difference between a sequence and a series? So that's something you want to know for sure. So a sequence is kind of just like a list of numbers, right? You see here all these numbers are separated by commas, so it's just a simple list, 1, 3, 5, 7, all the way to 21. But a series is when you take the sum of that list of numbers. So when you're adding each number, so 1 plus 3 plus 5 plus 7 plus all the way to 21, that is a series. So naturally, if we have the sum of a whole bunch of numbers, we might want to use the good old summation notation. Right? So remember the sigma is our summation sign. Right? We have a sigma here. This is a sigma sign, or that's the summation, which represents the sum of here from the first term all the way to the sixth term. Okay, now, before we can find the sum of something, it might be helpful if we have formulas. And by the way, I will provide you with these formulas on a quiz or test, so you don't have to try to memorize them. They will be provided for you. So you see here, this sum, this capital S means the sum. So the sum of n terms, so here this represents how many terms that we have. Remember that was our place. Equals n times the first term plus the nth term in that series divided by 2. So think about that. Maybe you want to think about that and figure out, why does that formula make sense? Why would we take the first term, the last term of the series, multiply it by however many terms we have and divide it by 2? So think about that. Does it make sense? Maybe you don't have to look at the formula because you're just going to understand what that means. Now, why does this formula become this one? Well, we're putting in the formula for nth term. Remember a sub n, what does that equal? That equals the first term times n minus 1 times d. Well, if it's the first term plus another first term, because we substituted in here, then we would end up with this. So again, if you're not sure and you're interested, ask me during class and I can explain it to you further. All right, but regardless, we're going to use those two formulas for this section. And that's the sum of a certain amount of terms in a series. So here, going back to sigma notation, we have the base down here. Sorry, this tells us what term we're starting with. So we're going to start with the first term. This tells us what term we're ending with. We're ending with the sixth term. We can either write it out, so that would be 4 times 1 minus 1 plus 4 times 2 minus 1 plus 4 times 3 minus 1 plus 4 times 4 minus 1 plus 4 times 5 minus 1 plus 4 times 6 minus 1. But that would take a lot of time, potentially. We have to write it all out, then we have to calculate it, right? 4 minus 1 is 3, 8 minus 1 is 7, 12 minus 1 is 11, 16 minus 1. 20 minus 1, 24 minus 1, and then we'd use our calculator to find that sum, right? So what's an easier way perhaps that we could have done that? Well, we could just use this formula, right? So maybe I even want to use this formula, it doesn't really matter. But here, if I plug in the number 1, I can find my first term is 3. So there's 6 terms, so if I'm using this formula here, there's 6 terms. My first term is equal to 3. My last term of the series I would find by plugging a 4 in here. 4 times 6 is 24, minus 1 is 23. And then, so I add 23 plus 3 is 26. I multiply 26 times 6, and I get 156. I divide that by 2. What do I get? 78. So it looks like the sum of these terms is 78. Let's check it. 10, 21, 36, 46, 55, 56, 57, 58, 68, 78. So yep, this equals 78. So no matter which way we do it, we get the same answer. So you either spend a lot of time writing it out, or you simply recognize, plug in the 1 to get the first term, plug in the 6 to get the sixth term. This represents how many terms we have. Use the formula. All right, number 2. So let's move on to number 2. Find the sum of the first 50 terms of the arithmetic series given the start is 4, 8, 12, plus 16, etc. So you can clearly see that a sub 1 is equal to 4. We should be able to get n, right? We're asking about the sum of the first 50 terms, so we know n equals 50. So now we either have to get d or we have to get a sub n. Which one do you think is easier to get? So go back and think, what does d represent? I think d is easier to get. D represents what? That's the common difference between the terms. So if these were separated by commas, right, 8, 4, 8, 12, 16, well, what would that common difference be? You would find your d by taking the second term and subtracting the first term from it. So 8 minus 4 is 4. Therefore, our common difference is d. So we no longer need a sub n because we can use the formula that doesn't have the a sub n, which is this formula up here. Right, so the sum of the first 50 terms equals 50 divided by 2 times twice the first term plus 50 minus 1 times our common difference of d. So again, where am I getting that? I'm getting that from our formula up here above. So now I just have to simplify what's inside this parentheses and then multiply it by 25. So I see it's 8 plus 49 times 4. So inside the parentheses, I get 204, and then I multiply that by 25. So to me, it looks like the sum of the first 50 terms is 5,100. Okay, let's move on to example 3. In training for a marathon, an athlete runs 7,500 meters on the first day, 8,000 meters on the second day, 8,500 meters on the third day, each day running 500 more than before. How far will an athlete have run in all at the end of 30 days? So at the end of 30 days, what does this represent? This represents our n. All right, we want to know after 30 days. What's our a sub 1? Our a sub 1 is 7,500. What's our common difference? Our common difference is 500, as stated here in the sentence, in the problem. So again, I just take these numbers, it's the same as the one up here previously, and I just plug them into the formula right here. So S sub 30 equals 30 divided by 2 times 2 times our first term, which is 7,500, plus n, which is 30 minus 1, times our common difference. So let's figure it out. 2 times 7,500 plus 29 times 500 I get 29,500. I have to multiply that by 15. So I see by the 30 days, the runner has run 442,500 meters. Okay, so what does that mean, meters? Well, usually We're more familiar perhaps with kilometers. So think about that. How many kilometers is that? So you should be able to do that translation really quickly in your head. You just simply divide by 1,000, right? So especially you runners out there, you should be able to figure that out. So figure that out, and there you have it. So it doesn't say which way, it doesn't say you have to give your answer in kilometers, so really this is fine, but just if you're thinking, wow, that's a huge number, well remember it is, of course, meters and not kilometers, so that might put it into a little more perspective. It is a lot though. Okay, finally, number 4. Fred is building a log house for his children. How should he cut a 10-foot log to get the 5 logs needed if each log is to be 8 inches longer than the one before it? So one thing you need to notice is that we have a 10-foot log, and they tell you that each log that's cut needs to be 8 inches longer than its previous log. So we have inches, we have feet, so obviously there's a reason that this was given. 12 inches equals 1 foot. Now what is the 10 feet representing? So 10 feet times 12 inches, right? Sorry, there's 12 inches in a foot. So we have 120 inches per foot, or sorry, per 10 feet. Now what is this representing? That's representing the total sum, that's our original total sum that we have. The sum of what? Well, the sum of the 5 logs needed to cut. So what does n equal then? N equals 5. S sub 5 equals 120 inches. And what does the 8 inches represent? Well, hopefully you're thinking that means common difference, right? 8 inches is how much more, so therefore every time we're going to add on 8 to get the next term. In other words, that's our common difference. So we do 120 equals, this time we're going to put our 120 here, that equals 5 divided by 2 times twice a sub 1. We don't know the first term, that's what we're trying to figure out. Twice times a sub 1, the first term, plus 5 minus 1 times our common difference of 8. Now we're going to simplify. So 120 equals 5 halves. I get twice a sub 1 plus 32. If I multiply the other side by 2, right, so now I'm doing some algebra, multiply each side by 2, I get 240 equals 5 times twice a sub 1 plus 32. Now I have to distribute my 5. So I have to move over here, sorry. 240 equals 10 a sub 1 plus, what's 5 times 32? That's 160. I subtract 160 from both sides. So 10 a sub 1 equals 240 minus 60, which is 80. Divide by 10. So the first term is 8. Well, we were in inches, so my first log that I cut needs to be 8 inches long. So what does the question say? It says, how should he cut a 10-foot log to get 5 logs needed? So this is the first cut he needs to make. So it needs to be an 8-inch log, and then 8 more than that is 16. 8 more than that is 24. 8 more than that is 32. 8 more than that is 40. So we can add it up really quickly to see if that works. So 8 plus 16 plus 24 plus 32 plus 40. And does that equal 120 inches? Yes, it does. So we know that these are the lengths of the 5 logs. And all of them, of course, should have the inches next to it. And that's it for an arithmetic series. Next will be a geometric series. See you then, or talk to you then.